page 87, continuing lesson 2.1 on combining like terms to solve equations. So example 2, Celine bought a computer screen on sale for 35% off the original price. What was the price of the computer screen before the sale? So if you look at the picture over here, you can see it's 35% off. You can see the sale price is $130. So one thing what the book did here is they said what we're trying to find is the price of the screen before the sale. So they said let's make that be our variable. So let P be the price of the screen before the sale. If you want to use a different letter, that's fine. And then they're saying we've got the $130 is what we're going to pay plus the 35% of the original price. If we add those together, that would be what the price was originally. Now, if that doesn't make sense, just hang with me because I'm going to explain it a little different than the book is in just a minute. Okay, so if we do this, then, well, basically what they're saying from this bar diagram is a little different than what their equation is. They're really saying 130 plus 0.35p equals 1p. Those two pieces of that bar diagram add up to be 1p. That's really what they're saying. And then to solve that, you could subtract 0.35p on both sides. When you do this, 1 minus 0.35, you'd have to line up your decimal points. Whoops. And that would be 0.65p. So if you'll notice what we're subtracting there, if you'll notice what we've got now is the same as what the book has. Okay? I think maybe what they were trying to avoid was having a variable on both sides of the equation because we haven't really dealt with that yet, but it's a similar concept to what we've done before. As long as we do the same thing on both sides of the equation, we can do that. If you look at where we're at this point in the problem, basically what we're saying, 0.65, that's kind of like our percent as a decimal. So 0.65 would be the same as 65%, right? So we're saying 65% of the original price is $130. And that's where we're at, really, because here's a different option than what the book's doing, if this makes more sense to you. So another way of thinking about this, if you're going to pay full price for something, the full price of something would be 100%. So in this example, it's 35% off. So what we could do is we could subtract 35% from the 100% to figure out what percent are we going to pay. If you do 100% minus 35%, you'll get 65%. So that means we're going to pay 65% of the original price. So if we're paying 65% of the original price, what we can do is we can change 65% to a decimal. Of usually means multiply. And we said the original price is what we were trying to find, so that was our variable. So 65% of the original price equals that $130. So this would be a different approach you could take rather than doing the bar diagram or thinking it out like the book did. This would be a different way that you could go to work that out. And then like the book shows, our last step, they're multiplying, so we would need to divide by 65 hundredths. And then we would get 200. The reason the number's getting bigger is because we're dividing by a number less than 1. So we would expect the price should have been higher before it went on sale, and that's the case. It was $200, and now it's on sale, and now it's $130. A way we could check that is you could figure out what 35% of 200 is. 35% of 200, and it should be $70. And then you could say it was $200. We take off $70 is $130. So that works. That means we had the right answer. So if we look at the try it, Nat's grocery bill was $150, which included a 5% club discount. So the question is, what was Nat's bill before the discount? And they want us to write and solve an equation. Okay, so like we did in the last problem, you could think about, what would it be if we were paying the full amount? What percent would we be paying? And then with the discount, what percent are we paying? And that would be a way that we could work this out. One thing that's probably a good idea to start with before you really even start working the problem is to define your variable. So we could say, let B represent Nat's bill before the discount. Since that's what we're trying to find, that's going to be our variable here. And then we can think about what percent we're going to pay and then come up with an equation based off of that is one option. So full price would be 100%. We're saving 5%. So if we take off 5%, 100% minus 5% is going to be 95%. Okay, so 95% of the original bill is what we've got here. And they're telling us that that was $150. So if we want to make this to an equation, we can change the percent to a decimal, or you could change it to a fraction if you'd rather, and then we can work that out. So if we do this as a decimal, 95% would be 95 hundredths, 0.95. So this is 95% of the original bill. B was the original bill, so 0.95 times the original bill. 95% of the original bill is equal to the $150 that they're paying. And then from that equation, we'll be able to figure out what the original bill was. So in order to solve this, variables being multiplied by 0.95, we can divide by 0.95 on both sides. And like the previous example, we're dividing by something less than 1 is going to make this be a bigger answer. What we're going to have to do here, if this doesn't come out, is we're going to have to round this off to the nearest cent, which is the nearest hundredth. So if we round that off, it's going to be about $157.89 would have been the original price. Example 3, they want us to solve this equation. What they're pointing out is that we have like terms to combine with negative coefficients. So with the negative coefficients here, those y terms can be combined. What you may want to do, like we did with subtracting integers, you may want to add the opposite. So change subtraction to addition. Opposite of 6.2 is negative 6.2y. At that point, then, we're combining those together. These are both negative, so they're working together here when we are adding. They're working together, so it's like we're adding those together. So 3.5 plus 6.2 is 9.7. Those are all negative, so that means we've got a negative 9.7y. And then the last step is they are multiplying by negative 9.7. We need to divide by negative 9.7 to get those to cancel. And when you work that out, it comes out to be y equals 9. And like we've done before, you can always substitute that back in the original equation to make sure that it works. So if we look at the try it, they want us to solve for D. So try it part A. So a couple things that we may want to consider when we're starting this problem. One thing is that since they're subtracting, we may want to add the opposite here. Make our two sign changes, add the opposite. The other thing is then, if we're adding these fractions together, we're going to have to get a common denominator. So with 4 and 5, a common denominator would be 20. So that means we could multiply on the first fraction, multiply the numerator and denominator by 5. The second fraction, multiply numerator and denominator by 4. We have to have common denominators when we add or subtract fractions. These are like terms then that we can combine together. Would be negative 13/20 D. Working together. To solve this then, they are multiplying, so we could divide by negative 13/20 to get those to cancel. So when you go to do that, it's 39 divided by negative 13/20. 39 we can put over 1, and we can keep change reciprocal. The negative can go either spot in that fraction. I like to keep the negative up in the numerator, but if you want to keep it next to the 13, you can do that. You could actually reduce the 13 and the 39 here by 13. We may not see that though, so if you don't see that, if you just multiply across, that would be negative 780 over 13. And then if you divide that out, you should get negative 60. So D equals negative 60 would be our answer for that problem. So part B. First thing on part B, I'm going to add the opposite here. And then we can combine those like terms together. This time, if you'll notice, we've got now, by adding the opposite, really we've got the first is negative. You don't have to rewrite this, but just to make sure everybody understands what's going on at this point. Now it's like we're adding these, but some are negative and some are positive. So it's like they're working against each other. So we can subtract these because we have some positives and some negatives. They're working against each other. Kind of like if you had $12.81 and you owed $9.76. You're going to have $3.05 left. So this is 3.05D equals 8.54. At this point they're multiplying, so we can divide by 3.05. We could divide that out by hand, but we could probably use a calculator if we're allowed to, and that would be 2 8/10. Key concept, just recapping, the idea about combining like terms on one side of the equation and then using opposite operations to solve. We'll look at the do you know how number 5. A city has a population of 350,000. Population has decreased by 30% in the past 10 years. What was the population of the city 10 years ago? Okay, so if you think about it, they had some population, and then it went down by 30%, and then now we're at 350,000. That would be a way of kind of visualizing what's happening there. So if we let P represent the population of the city 10 years ago. So one option for working this out, we could say we had the population, we took away 30% of the population, and now we've got 350,000. The other option you have is you could say we had 100% of the population, we lost 30%, so now we're at 70% of the population. If you do it the first way I mentioned, that P is the same as a 1P. 1P minus 0.30P would be 0.7 or 0.70P. And if you think about it, really this is what we'd have doing it that second method. If you have 70%, that's the same as 0.7 or 0.70. We can keep the 0 there if you'd like. 0.70P. And then when you divide that, that's going to be what the original population was, which should be 500,000. We had 500,000, we lost 30%. That means we had that gave us then 350,000 people. Look at number 6. In order to solve this equation, we've got subtraction going, so we may want to go ahead and add the opposite here again. Change subtraction to addition. Opposite of 13.4 is negative 13.4. So now that we've added the opposite, we have like terms here that we can combine together. In order to combine those together, this time they're working together. We got some negatives, we got some more negatives, so we're going to have a bunch of negatives here. So that would be 25.6, and those are all negatives, so negative 25.6Z. And then they're multiplying so we can divide. On the Z, I put a line through the Z. I don't write my 2's that way, but for people that write their 2's differently, the 2 and the Z can look very similar, so that's the reason why. A lot of times you'll see that with the line drawn through it. When we divide this out, negative divided by negative is positive. And when you divide the numbers out, that would be 7. So Z equals 7 would be our solution to that problem. So this gives you an idea of how to combine like terms to solve equations. Have a good day.